Space weather is something we experience because we live near a star, the Sun. But solar activity may not be the only cause of disturbances in our upper atmosphere. Out in the countryside near Boston, Massachusetts, scientists at MIT's Haystack Observatory are looking at other actions in our lower atmosphere that might also be stirring up a little space weather.
In previous episodes of Space Weather FX, I've talked about what happens during solar outbursts, when material from our sun impacts our upper atmosphere. But the sun isn't always sending big blasts of charged particles our way. For the past couple years, it's been extremely quiet. We've seen very little in the way of big space weather. This period, which we call solar minimum, is an excellent time to look at other events in our atmosphere that drive space weather activity in the ionosphere. My colleague Dr. Larisa Goncharenko here at Haystack Observatory has been studying what are called stratospheric sudden warming events. She and her colleagues have found a kind of space weather that seems to go not from the top of our atmosphere down, but from the bottom up. I recently spoke to Larisa about the characteristics of a stratospheric sudden warming event.
Stratospheric sudden warming is a large-scale dynamical feature in a wintertime polar stratosphere at altitudes between maybe 20 to 50 kilometers above the ground.
So these events are in the layers of the atmosphere that are closer to the ground and closer to the types of weather that meteorologists would study.
Yes, this is correct. And this type of event involves really profound changes. For example, temperatures can rise up to tens of degrees, and wind changes from winter-type pattern to summer-type pattern. These events were discovered in 1950s, and since then they attracted a lot of attention from researchers from different fields.
So Larisa, can you tell us how changes in the stratosphere affect weather in the upper atmosphere?
In 1980s, scientists discovered that warming in the stratosphere is accompanied by cooling in the mesosphere, which is at altitudes between maybe 70 to 90 kilometers. Up to now, it wasn't known if any changes occur at higher altitudes. In January 2008, our Haystack Observatory group, together with colleagues from other research organizations, carried out a major experiment to see if any changes that occur at altitudes above 100 kilometers. What we saw exceeded our highest expectations. We saw that when stratospheric warming occurs at polar latitudes, and it accompanied by mesospheric cooling, which we knew before, but we saw another layer of warming at altitudes about 120 kilometers, and large cooling all the way up to several hundred kilometers.
So the changes seen were larger than expected before these experiments were conducted.
This is the first time it was seen.
You also found changes that occur not only as a function of altitude, but also globally from the pole to the equator.
Yes, in fact we found that this is really a global event.
This work also shows that the strength of the connection between the lower and the upper atmosphere is much stronger than previously expected.
This is a great mystery which we are trying to solve right now.
So Larisa, how do these changes connect to what we would normally think of as space weather?
This work actually shows that space weather can happen for different reasons, and upper atmosphere can vary a lot even when the sun is really quiet. In fact, making such observations during very low solar activity really helps us to understand what exactly drives variations in the upper atmosphere. People suspected a long time ago that lower atmosphere can affect the state of the upper atmosphere, but it was very difficult to study because sun is such a major driver of the space weather. And now, during solar minimum, when sunspots and solar activity is out of our way, this is a perfect time to focus on this type of study and see what exactly drives the coupling between lower and higher altitudes.
So these studies have uncovered a new type of space weather that was really there all along, but was very difficult to detect until recently.